Hello everyone, this is Sammy Ayo with SAA Services, back with you again. I have another project for today. A friend of mine dropped off a stainless steel crawfish pot. It was given to him, but whoever had it before, someone ran a fire under it without any water in it, and they heated up the bottom of the pot to the point where it cracked. So he wants me to fix the cracks in the crawfish pot. So I don't know if you can be able to see these very well, but I've marked them with permanent marker, and I'm trying to hold this up to show it to you all at the same time. It's kind of difficult. Let's see. So I've marked it. I got a crack here, several little hairline cracks throughout here, and this is stainless steel. And I can't just weld this on the bottom side without sugaring the back side of this, the bottom side of this pot, the inside. So in order to keep it from sugaring, and that's what happened with stainless steel and any kind of what you call an alloy, which is anything, almost anything other than carbon steel, stainless steel, titanium, super duplex, any kind of alloy has to have an inert gas purge on all sides. It has to be surrounded by inert gas. So what you would do on pipe weld or anything like that, you would run another argon hose inside your pipe, and that's how you, what they call back purge a weld. Well, obviously this is kind of a large piece, so what I'm going to do here is I'm going to take this piece of cardboard, and I've already drawn this, I put the pot on it, and I drew my circle out, and I'm going to cut this out. I'm going to cut it a little large, about 1 inch large, and then I'm going to cut little slices in it along the edge, and I'm going to put this inside the pot, and I'm going to put a little hole right in the middle, and I'm going to run me a back purge hose to the inside, and that's going to provide my back purge so that while I'm welding on this pot, I won't sugar the inside of the pot, the opposite side of where I'm welding at, because that heat will cause it to sugar. So let me get this all set up, and I will show you what I got going, and we'll make this weld and get my friend's seafood boiling pot ready for him to weld. It's getting crawfish season now, so I'm sure he's probably waiting on it. I've had this thing way too long, but I had to wait for a valve. I needed a special valve so I could run my second argon hose off of it. Well, anyway, let's get started. Okay, so what I did was, as I showed you, I cut that piece of cardboard out, and I shoved it down in there. I cut the cardboard a little wide, and then I made slices all around the edge of it so that when I pushed this down in here, the edges would fold out, and I'd have something to put my tape on and tape it to the side of my pot. And here's my back purge hose. So what's going to happen is I'm going to run this hose along with, in conjunction with my TIG torch hose, to provide gas on the inside of this pot, and that's going to give me an inert atmosphere on both sides of the weld, and that will keep the weld from sugaring on the inside of this pot. When I weld it outside, the inside won't sugar. So I'm going to seal this up a little bit better. I want to make sure I got a good seal, and I'm going to put some tape around the hose here and make sure I got a good seal. You want to have a little bit of a vent, but not much, because of course it's going to build up some pressure in there from the gas going in there. But just you can, I'm going to seal this up, and I think I'm going to punch me another couple of holes inside in the cardboard, and that way I know I have a good flow of gas, a good back purge on the back side of this thing, to again keep it from sugaring on the back side. So I have taped my back purge hose into the hole in the cardboard back here. I taped on in to make sure I have a good seal. And you're not going to be able to see in this video, but I also punctured 4 crosses in 4 different locations around here. You can't see them. They're really, really small. All of this is to relieve the pressure that I'm going to build up in here with the back purge. And we're fixing to, I'm going to take a wire wheel and clean off where I got these holes marked, these cracks marked. I don't know if you can see them, probably not. But I'm going to take a wire wheel, clean them off real good, and I'm going to weld these up. So I have my welds all cleaned up, ready to weld. I'm going to weld this using the gas tungsten arc welding process, GTAW, most commonly referred to as TIG, or in the old days they called it heli-arc. In the old days they used a lot of helium to weld with. But we're going to use a TIG welder. TIG welding is a direct current process. All welding is done direct current, either reverse polarity or straight polarity. TIG welding is with straight polarity, meaning the base metal here, the pot, is positive. My tungsten, this is my electrode. If you're wire feed welding, this is the wire feed I have beside me here. It feeds either a hard wire, which is GMAW, gas metal arc welding, or a flux core wire, which is FCAW, flux core arc welding. If I'm behind me, the machine I'm using to TIG weld with, I can also weld with SAA process, which is commonly referred to as stick welding. In those processes, you're welding direct current, reverse polarity. With this, your base metal is negative and the wire coming out of your wire feeder is positive. Same way with your SMAW stick welding. Your base metal would be negative and your welding electrode with stick welding, everybody calls it a welding rod, but it's not a welding rod. A welding rod is what I'm going to use to fill these cracks in, TIG welding. In SMAW stick welding, that's a welding electrode. Anyway, in all of those processes, the electrode is positive. In this process, and only this process, do you weld with the electrode. The tungsten is negative. This will not burn. The pot will burn, the base metal, and the TIG welding rod I'm going to use to fill these cracks in with is a welding rod. The pot will burn and melt, and the rod will melt. This will not melt. This is only creating the current and the arc and the puddle. So I'm going to place this in my TIG torch. This is the TIG torch. I'm going to stick my tungsten out about a ½ inch. And I have grinded my tungsten to a very small point. This is going to require a lot of control and tedious welding. So I got a very good sharp point on there. And we're fixing to get this weld going and fill up these cracks. I can see 1, 2, 3, 4, about 5 good cracks, and they're more going to show up as I'm welding. As this metal heats up and shrinks, it's more going to show up. Then I'm going to go ahead and get my buddy's crawfish pot all ready for him to start boiling seafood in. Okay, so we're fixing to get started. As you can see, I have a remote amperage control. I'm using my foot right here, the remote amperage control. So I'm going to use remote amperage control to do my best to control this heat. And we're going to start with this first big crack right here and try to get this thing welded up for my friend. Okay, so I was having problems with my gas flow. I was running 2 lines at one time. I had to turn my flow meter up a little bit, trying to conserve my gas. I don't have a whole lot of gas to finish this weld up with, but I should have enough. I'm using 100% argon. And I'm trying to hopefully be able to let you all see me make this weld, but I'm not sure if it's going to show up on camera or not, but I'm going to do my best here. And I just realized I don't have a ground. I now have a good ground, and we got gas flow. And let's see if we can't seal up these cracks for my friend. Well, I believe we have successfully filled that one spot up, and we have several more to go. So let me continue getting these things filled up for them and try to make this weld repair for them. All right, so I think we have it all patched up. As you can see, I got a lot more welds on here than what I had marked off. That doesn't surprise me. I had a good suspicion that as I welded one spot, more cracks were going to show up. That's what happens when you heat metal up, and as it shrinks down, it's going to shrink smaller than what it originally was, and that's going to open up more cracks. But it appears so far that I have sealed off all his cracks, and I believe he should be good to go. I think this will hold water for him. Anyway, I hope this video was interesting and helpful and informative, and I hope you all please subscribe, like, and share my channel, my YouTube channel, and share my information with other people. Y'all have a blessed day.